Morning everyone. Good morning everyone. Let us start our class. New topic is Maxima and start our Can you hear me? Okay, let us start. Can you hear me? Maxima and Minima. Okay, let us. Can you hear me? Maxima and Minima. So let us consider a graph here. In the interval B I, consider a point C in the interval I. If f of x is less than or equal to f of c for all x belongs to I, x is called the point of maximum value C is called the point of maximum value and f of c is the maximum value of the function. See, f of x is less than f of c. For all x belongs to I, then C is called the point of maximum value. See, this C is called the point of maximum value and f of c is the maximum value of the function. So let us consider this example here. A point C, you can take any point here. If we are taking this point as C, then f of c is the length of this line segment. Okay, that is, this point, coordinate of the point is c, f of c, and here the x coordinate is c. This c means it is the distance from the y-axis and f of c means it is the distance of this point from the x-axis. So the length of this line segment gives f of c. In this case, if we consider this point, let this be equal to c1 Then C f of C1 is the C1 f of C1 is the coordinate x coordinate and y coordinate of this point. So here this length f of C1 is greater than all other f of x here. So this line is the longest line here. That means f of C1 is greater than f of C for all x belongs to this I. Then C is called the point of maximum value and f of C is the maximum value of the function. You can write down this definition. If f of x is less than f of C for all x belongs to I, then C is called the point of maximum value and f of C is the maximum value of the function. Similarly, you can define the point of minimum value and the minimum value of the function. That is, if f of x is greater than f of C for all x belongs to I, greater than or equal to f of C for all x belongs to I, then C is called the value of x. C means it is the value of x. C is called the minimum, the point of minimum value, and f of C is the minimum value of the function. If f of x is greater than f of C for all x belongs to I, C is called the point of minimum value and f of C is the minimum value of the function. So in this case, if we consider this point as C, this as C, then f of C is the length of this line segment. F of C is less than all other f of x. So this point C is called the point of minimum value and the corresponding value of the function f of C is called the minimum value of the function. X coordinate is the point of minimum value or point of maximum value and the y coordinate is the maximum value or minimum value of the function. So you have to make clear this point. Point of minimum value is the x coordinate and the minimum value is the y coordinate of that point. That is f of C. Now let us move to the next term, monotonic functions. Monotonic functions. Write the definition. A function f in an interval I is said to be a monotonic function if it is either increasing or decreasing in I. It is either increasing or a decreasing function in I. See, a function f in an interval I is said to be a monotonic function, or it is called a monotonic function if it is either increasing in the interval I or decreasing in the interval I. A function f in an interval I is said to be a monotonic function if it is either increasing or decreasing in I. For example, let us consider f of x is equal to x in x belongs to closed interval 0, 1. So if we consider f of x is equal to x in the interval 0, 1, closed interval 0, 1, then we know that as x increases, the value of f of x also increases. So it is an increasing function. Okay, in this case we call this function as a monotonic function because it is an increasing function here. If we write f of x is equal to minus x, f of x is equal to minus x, then it is a decreasing function. So in that case also we call this as a monotonic function. Either increasing or decreasing functions are known as monotonic functions. And now the result, every monotonic function attains its maximum or minimum value in the endpoints of its domain of definition. So every monotonic function attains its maximum or minimum value in the endpoints of its domain of definition. For example, let us consider this one. This is a monotonic function. If we put x is equal to 0, f of x is equal to 0. Okay, f of 0 is equal to 0, which is less than all other f of x. If we put x is equal to 0, f of 0 is equal to 0. We can write f of 0 is equal to 0, which is less than all other f of x here. Therefore, 0 is called the minimum point of minimum value, and f of 0 is equal to 0 is called the minimum value of the function, which is attained in the end point of this interval. Similarly, if we consider f of 1 which is equal to 1, which is greater than all other f of x. Therefore, 1 is the maximum value of the function which is attained at the point x is equal to 1. So this 1 is called the point of minimum value, and this 1 is called the maximum value of the function. So every monotonic function attains its maximum or minimum value in the end points of the domain of definition. Okay, let us consider some more questions of exercise 6.5. Find, write the question, find the maximum or minimum values of the following functions. Find the maximum or minimum values of the following functions. Write the first one. F of x is equal to 2x minus 1 the whole square plus 3. See, in the question it is given that f of x is equal to 2x minus 1 the whole square plus 3. Let us find let us write this as 2x minus 1 the whole square. This is a perfect square, so you know that this is greater than or equal to 0. Okay, 2x minus 1 the whole square is greater than or equal to 0 as this is a perfect square. And if we add 3 to both sides of this inequality, it becomes 2x minus 1 the whole square plus 3 is greater than or equal to 3. Adding 3 on both sides. Okay, so this one is 2x minus 1 the whole square is positive, and adding 3 to both sides it is greater than or equal to 3 here, and you know that this is given as f of x, isn't it? 2x minus 1 the whole square plus 3 is given as f of x, so we can write f of x is greater than or equal to 3. Whatever be the value of this x, it is always greater than or equal to 3. What is the meaning of this one? The maximum, the minimum value of the function is 3. All other values of this f of x is greater than 3. So the minimum value of the function is 3. What will be the point of minimum value? Can you say what will be the point of minimum value? That is, at which point you are getting this is equal to 3. At what value of x this f of x will be equal to 3? If you have to get the point of minimum value, see, this must be equal to 3. That is 2x minus 1 the whole square plus 3 must be equal to 3. And 2x minus 1 the whole square is equal to 0. 2x minus 1 equal to 0. X is equal to 1 by 2. So the point of minimum value, it is not asked here in the question. But if we have to find the point of minimum value, this is what I have to do. minimum value of the function is 3 and it is at the point x is equal to 1 by 2. So x is equal to 1 by 2 is the point of minimum value and the minimum value of the function is 3. So let us consider another one. F of x is equal to minus of x minus 1 the whole square plus 10. Minus of x minus 1 the whole square plus 10. So we know that x minus 1 the whole square, as it is a perfect square, it is greater than or equal to 0. This number is a positive number. So if we put minus sign here, minus of x minus 1 the whole square multiplying with a minus 1, multiplying an inequality, both sides of an inequality with a negative number, the sign of inequality should be reversed. In your 11th standard, you are learning this property. If we multiply or divide with a negative number, then we have to reverse the sign of inequality. So here this is greater than or equal to 0 and minus of x minus 1 the whole square is less than or equal to 0. Okay, now we are adding, here it is plus 10. So adding 10 to both sides, minus of x minus 1 the whole square plus 10 is less than or equal to 0 plus 10, it is 10. And this is f of x. It is given in the question. This is given as f of x. F of x is less than or equal to 10. Whatever be the value of x, the value of f of x is less than or equal to 10. That is 10 is the greatest. So the maximum value of the function is maximum value of the function is 10. And what will be the point of maximum value? Give your answer. The maximum value of the function is 10. So f of x must be equal to 10. F of x is equal to 10 at x is equal to at x is equal to okay, all of you are coming with the answer 1. Isn't it? This must be equal to 10. Therefore, x minus 1 is equal to 0. X is equal to 1. So, the point of maximum value is x is equal to 1. Okay, let us move to the next one. Third question. F of x is equal to 9x square plus 12x plus 2. F of x equals 9x square plus 12x plus 2. So let us write this function as 3x. 9x square is square of 3x plus Let this be equal to 2 into 3 into 2. So let this be equal to 3x plus 2 the whole square. When you expand this, you will get it as 9x square plus 12x 2ab. 2 into 3 into 2. 12x then plus 4. But here it is only plus 2. So we have to write minus 2 here. By the method of completing squares. Okay, 3x plus 2 the whole square. Now this is again here in this 3x plus 2 the whole square, as it is a perfect square, this is greater than or equal to 0. So 3x plus 2 the whole square, subtracting 2 from both sides, greater than or equal to minus 2. Subtracting 2 from both sides, we will get this as 3x plus 2 the whole square minus 2 is greater than or equal to minus 2. So this is f of x greater than or equal to minus 2. Whatever be the value of x, f of x is greater than or equal to this minus 2. That is, the minimum value of the function is minus 2. Minimum value of the function is minus 2 and the point of minimum value is, what is the point of minimum value here? Point of minimum value is okay, almost all of you are coming with the answer minus 2 by 3, right? This is equal to C minus 2. Then minus 2 get cancelled. 3x plus 2 must be equal to 0. That is, x is equal to minus 2 by 3. So the point of minimum value is minus 2 by 3. Now let us consider another one. F of x is equal to x cube plus 1. F of x is equal to x cube plus 1. So here in this case, if we consider the value of x as negatives and taking x as smaller values, then the value of f of x will become more and more smaller. And if we consider x as a positive number, then the value of f of x tends to positive infinity. Okay, if x is taken as a negative number, the value of f of x tends to negative infinity. And if we consider larger values for this x, that is positive values, then f of x tends to infinity. So we can say that f of x has neither maximum nor minimum value. As x increases, value of f of x increases, and as x decreases, f of x also decreases. So here we cannot find a maximum or minimum value. Therefore, f of x has neither maximum nor minimum value. Okay, is it clear? If we take negative values for this x, that is if we are moving towards left of the number line, then this x cube becomes smaller and smaller. X cube plus 1 also becomes smaller and smaller, and it tends to negative infinity. And if we move towards the right of the number line, that is larger values for this x. If we give larger and larger values for this x, then f of x tends to positive infinity. F of x also increases in this case if we take x as positive. So f of x has neither maximum nor minimum value. Okay, let us move to the next one. F of x equals modulus of x plus 2 minus 1. Modulus of x plus 2 minus 1. So here in this case, modulus of x plus 2 is always greater than or equal to 0. Isn't it? And modulus of x plus 2 minus 1 is, subtracting 1 from both sides, we will get this as modulus of x plus 2 minus 1 is greater than or equal to minus 1. That is, f of x is greater than or equal to minus 1. Therefore, the minimum value of the function is minus 1, and the point of minimum value is this must be equal to 0, so x is equal to minus 2. Okay, let us move to the next one. G of x is equal to minus of modulus x plus 1 plus 3. g of x is equal to minus of x plus 1 plus 3. Try to do this one yourself. And give your answer. G of x is given as minus of modulus x plus 1 plus 3. Find out whether a maximum or minimum value is there. If so, which is the value? G of x is given as minus of modulus x plus 1 plus 3. Give your answer whether this function has a maximum value or a minimum value. The maximum value of the function is, okay, almost. So we can write this as, your answer is maximum value of the function is, okay, Parvati, Anjana, Tejas, Praveena, Ashwin. Okay, all of you are coming with the answer, this 3. Let us see this one. Modulus of x plus 1 is greater than or equal to 0. Negative of this modulus x plus 1 is less than or equal to 0. Then minus modulus x plus 1 plus 3 is less than or equal to 3. F of x is less than or equal to 3. So for all x in the interval, in the domain of definition of this function, f of x is less than or equal to 3. That is, the maximum value of f of x is 3. And it attains at the point of maximum value is x is equal to x is equal to minus 1. Okay, let us move to the next one. H of x is equal to sin 2x plus 5. H of x is equal to sin 2x plus 5. What can you say about this value of sin 2x? Sin 2x lies between minus 1 and plus 1. Range of the function, sin function is closed interval minus 1, 1. So the value of sin function always lie between this minus 1 and 1. that is minus 1 less than or equal to sine 2x less than or equal to 1. Okay, so let us add 5 with this. This gives double inequality here. So we have to add 5 minus 1 plus 5 less than or equal to sine 2x plus 5 less than or equal to 1 plus 5. Here you will get this as 4 less than or equal to this sine 2x plus 5 is h of x, which is less than or equal to 6. If we consider this inequality, then we can say that h of x is greater than or equal to 4. Therefore, the minimum value of the function is 4. And if we consider this inequality, h of x is less than or equal to 6. So the maximum value is 6. So the function sine 2x plus 5 has a minimum value 4 and a maximum value 6. Okay, I hope it is clear to you. Let us move to the next one. F of x is equal to modulus of sine 4x plus 3. This is sine 4x plus 3. So how can we write this? The value of sine 4x lie between minus 1 and plus 1. And if we add 3 here, minus 1 plus 3 is less than or equal to sine 4x plus 3 less than or equal to 1 plus 3. So this is 2 less than or equal to sine 4x plus 3, which is less than or equal to 4. So if we consider the modulus of this one, taking modulus here, you will get the same. So it is 2 less than or equal to f of x less than or, because in between 2 and 4 all are positive numbers. So if modulus of positive numbers, that gives positive, so 2 less than or equal to f of x less than or equal to 4. Therefore the minimum value is 2 and the maximum value is 4. Okay, then one more question. f of x is equal to x plus 1, x belongs to open interval minus 1, 1. Consider f of x is equal to x plus 1 where x belongs to open interval minus 1, 1. See, here it is given that x belongs to minus 1, 1. That we can write as minus 1 is less than x less than 1. So if we add 1 here, because x plus 1 is the function given, minus 1 plus 1 gives 0 less than x plus 1 less than 2. That is 0 less than f of x less than 2. So what will be the minimum function and minimum value and the maximum value here? Can you say what is the minimum value of the function and maximum value of the function? What is the minimum value and maximum value of the function? Surely you will come with the answer. Minimum value is 0 and the maximum value is 2. But that answer is not correct. See now, here it is not given as an inequality 0 less than or equal to. Equal to sign is not here. Okay, this is given in an open interval. Always remember this one. If we consider an open interval, we write this inequality as a strict inequality. Okay, so here minus 1 less than x less than 1. It is not equal to. But in these two cases, see now here it is less than or equal to. That means h of x has a value 4. But here we cannot say such a value for f of x. A particular value we cannot specify here for f of x because 0 less than whatever be the number in between this 0 and 2. If we consider a very closer value, let c be a closer number to this 0, very close to 0, then f of c is c plus 1. Okay, c plus 1. In between 0 and c plus 1, we can find infinitely many real numbers. So again, less than that c plus 1, there are some numbers. Isn't it? If we consider x is equal to c, listen this one, x is equal to c, f of x will be equal to c plus 1. That is, this c plus 1 lies between 0 and 2 and it is very close to 0. But in between this 0 and this c plus 1, we can find infinitely many real numbers less than this c plus 1. So we cannot say that it has a minimum value or it has a maximum value. Always remember this one. If it is an open interval, the function f of x has no minimum value or maximum value. You can write the answer. F of x has no minimum or maximum value here. No minimum or maximum value. So let us move to the next definition. Local maxima and local minima. Write the definition now. Local maxima and local minima. Let f be a real valued function and C be a point in the domain of f, then C is called a local maxima if there exists h greater than 0 such that f of c is greater than f of x for all x belongs to c minus h, c plus h. Okay, see the definition. Let f be a real valued function and c be a point in the domain of f. Then c is called a local maxima. It is local maxima. See the term local maxima if there exists an h greater than 0 such that f of c is greater than f of x for all x belongs to c minus h, c plus h. In the first definition, we are considering the whole interval I. But here in this one, we are considering a very close interval to this c. H is greater than 0, h is a positive number. So c minus h lies to the left of c and c plus h lies to the right of c. So we are considering a very close interval to this c. A very small interval c minus h, c plus h. In that interval, if f of c is greater than f of x for all x belongs to this one, then we can say that c is the local maxima. The same definition here, f of c is greater than f of x. And the second one, c is called a local minima if there exists an h greater than 0 such that f of c is less than f of x for every x belongs to the interval c minus h, c plus h. And here in this case f of c is called the local maximum value, and here in this case f of c is called the local minimum value. C is the local maxima and f of c is the local maximum value. Here C is the local minima and f of c is the local minimum value. And write a theorem also. Theorem, let f be a function defined in an open interval I and let C belongs to I. Then x is equal to C is a local minima or a local maxima implies f dash c is equal to 0 or f is not differentiable at C. If x is equal to C is a local minima or local maxima, then f dash c is equal to 0 or f is not differentiable. Okay, so once again this definition, if f of c is greater than f of x in a very small interval c minus h, c plus h, then c is called the local maxima and f of c is called the local maximum value. And here f of c is less than f of x for all x belongs to a small interval c minus h, c plus h, then C is called a local minima and f of c is called the local minimum value. Now we have to learn some working rules to find this local maximum, local maxima and local minima. We will do it in the next class. Okay, thank you.